welcome back to West Virginia. Yeah? No. Anyways, joke of the day. So, why should you never use a dull pencil? Because it's pointless. I love joke of the day. It is the best part of the day. But speaking of good things, let's take a look at circles. So a circle by definition is a set of all points that are equidistant from a fixed point. Now let's take that definition and let's look at what a circle is, because watch very carefully at what I'm about to do. Like, don't even write, just stop and watch what I'm about to do. Most people, when they draw a circle, when they make a circle, including me, we all do this. We go like this, right? In other words, we draw the outside of the circle and then we put our center in there. But by the definition, that's not what a circle is. Because the definition says it's the set of all points that are equidistant from that fixed point. So based on that definition, we shouldn't do all this loopy part first and then put the center in. Based on the definition, what should happen is we should start with that fixed point, and that fixed point is what we call the center of the circle. We should start with that fixed point and we should go an equal distance. In other words, an equal distance. So it's almost like saying, I'm going to put a pin in this fixed point right here. I'm going to tie a string around my marker and I'm going to go out a particular distance. Once I've designated that distance, I'm going to make sure that that distance does not change as I loop around that center. And I'm not doing a very good job at all. Horrible artist. Anyways, but I think you get the point here of what that definition means. And I really wanted you to see that, because the definition says start with that fixed point, the center, come out that fixed distance, which we call the radius. So from here to here is what we call the radius, and that will give us a picture of that circle. So what I'm going to do now is I'm going to show you where the formula or the standard form, not formula so much, but the standard form of the equation of a circle comes from. So let's say we've got this center here, and it has an x and a y coordinate. But what I'm going to do is I'm going to call that x coordinate h, and I'm going to call that y coordinate k. That should feel very familiar. And so now what I'm going to do is I'm going to say this point out here, it's a generic point. I'm not sure where it sits in this 2D coordinate plane. So I'm going to call it x and I'm going to call it y. And what I'm going to do is I'm going to find the distance between these two. That should be familiar. That's your distance formula. So we need to recall what the distance formula says. It says if I want to get a distance, I need to take a great big huge square root. And underneath that square root, I'm going to subtract my x's. I'm going to square that. I'm going to subtract my y's. And I'm going to square that. And I'm going to add the two together. Now what I'm going to do is I'm going to take this distance formula, I'm going to apply it to my circle right here. So instead of d, I'm trying to find this distance right here, which I'm calling r. So I'm going to put an r in there. And now when I subtract those x's, I'm going to say, let's take this x and let's subtract that h. Now I could have done h minus x, but I just want to show you where the formula for that standard form of the equation of a circle comes from. So I'm going to subtract those x's and do x minus h. I'm going to subtract those y's and do y minus k. Now recall, we talked about distance formula before, and we said when I subtract those y's, even though on slope, you have to go in that same order. If I did x minus h, I have to go y minus k. But with distance formula, it doesn't matter, because I'm going to square it in the end. The squaring fixes where we might have subtracted in a different order. But I'm going to go ahead and go y minus k. I'm going to add them in between. And now what I'm going to do is I'm going to try to get rid of that square root. So to undo a square root, what does it take? Absolutely, I have to take this side and I have to square the side. And what I do on one side, I have to do on the other side, so I have to square that side as well. And that gives me r squared equals x minus h squared plus y minus k squared. Because remember, squaring and square rooting undo each other. It's completely gone. Now remember this idea of pan balance, and we talked about pan balance before, that this fulcrum in the middle of the pan, and we said if I take that pan and I spin it around, does it change the balance? No, not at all. It might teeter a little bit, but the balance is the same. So in other words, I can take what's over here and I can slide it to that side. I can take what's over there and slide it over to this side. So if I do that, then I have x minus h squared plus y minus k squared equal to r squared. And that, my friends, is the formula for the equation of a circle. It comes from this distance formula. So what that tells me is when I see this equation, I can pull out the center and the radius of the circle. That center is going to be this h and this k, and this should feel familiar because this kind of looks like a parabola. Remember, with the parabola, we had x minus h squared. Same stuff. Now recall that with a parabola, your graph looked like this, so it's kind of like a half of a circle in a way. So we only had half of it that was squared. Remember, we didn't have this y minus k squared. We just had a plus k. But if I'm going to loop this around and curve it off as well, then I'm going to square this piece as well. So this is what the equation of a circle, very similar to the equation of a parabola. Let me just go ahead and write that parabola formula in here, just to give you that comparison. So you see very similar right here to what you see right there. And if you remember, I said you've got to see that minus, and when you do, that h is going to be the x-coordinate of the vertex of your parabola. Same thing here. I have to see that minus, and when I do, this number right here that's been subtracted, that is the x-coordinate of my center of my circle. Center is kind of likening to this vertex on that parabola. Same thing here. I've got to see a minus. When I do, whatever's being subtracted will be the y-coordinate of that vertex. So that one, not vertex, I'm sorry, but center. So this will give me the center of the circle. Now be very careful with your radius. Recall the radius was r, and I have r squared here. So the radius is going to be r, not r squared. I have to be super, super careful about that. So now that I know that, let's take a look at a few examples of being able to work with this formula for the equation of a circle. So in the first example, it says, I'm going to write the equation of the circle. It says, I know the center is negative 2, 4. I know the radius is 4, and I want to write the equation that represents that circle. So I'm going to utilize that formula for the standard form of the equation of a circle, and recall, very much like a parabola, x minus h squared plus y minus k squared equals r squared. The h and the k come from the center of the circle. So I'm going to plug that in as x minus a negative 2 squared plus y minus 4 squared equal to 4 squared. And I'm going to clean up whatever I can. Clean up meaning we know, whoops, I need another parentheses there, I'm sorry. We know that subtracting a negative is really adding a positive, so I'm going to clean that up, and I'm just going to call it x plus 2 squared. This, I can't clean up at all, y minus 4 squared, but I do know that 4 squared is 16. And so this is the standard form of the equation of a circle. I do not need to FOIL this out. I do not need to FOIL this out because the directions just simply told me write it in standard form. Standard form keeps that parentheses in there and keeps that parentheses in there. Now then, if we take a look at this one, it says, what about a center at 0, 0? What does that equation look like? Now recall that the formula says x minus h squared plus y minus k squared equal to r squared. And I'm getting a generality here. Notice I'm not told what that radius is, so I'm not going to plug anything in for this radius. I'm just going to leave it as r squared. But I am told that my h is now going to be 0, my k is now going to be 0. So when I have that, I now have this, and I'm going to plug a 0 in for the k. And remember me talking about cleanup? Because I know that x minus 0 is just x. So I really just have x squared. And I know that y minus 0 is really just y. So I just have y squared. So in other words, when I see an equation that looks like this, that tells me that my circle circle has a center at 0, 0. In other words, when it doesn't look like something is being subtracted, that means you're subtracting a 0. And same thing here. When it doesn't look like there's being something subtracted, then you're subtracting a 0. And so that tells me when I see this, without a doubt, that center is going to be 0, 0. The radius will still be the square root of that number like you saw up here. Well, no, we're going to do it down here. I'm sorry. The radius is still going to be r, the square root of whatever that number is. So let's take that transition and let's move on down to this example. This one said, I'm going to be given the center and the radius. I'm going to write the equation. This one says, let's take the equation, let's pull out the center and the radius. Let's graph that circle, and then what feels like a new concept, getting the domain and the range, really isn't a new concept. We looked at that before. But let's start with getting that center and that radius. Now recall, the center is HK, and basically what that means is whatever is being applied to the x, that is going to be the x-coordinate of your center, just like we did with parabolas. Remember with parabolas, we said whatever was being applied to, here's my parabola, whatever was being applied to that x was going to be the x-coordinate of the vertex. And the same idea right here. Whatever is being applied to the x is going to be the x-coordinate of the center. So what's applied here is a 3. Remember, I've got to see that minus, which I do see, so that means my center's, the x-coordinate is going to be 3. Just like with a parabola, some people prefer to say, I'm just going to do the opposite. The opposite of a minus 3 is a positive 3, whichever way you're comfortable with. So if I need to see a minus here and I don't, then remember that means that I am subtracting a negative 5, which means my y-coordinate of my center is negative 5. Or, like I said, some people prefer to say, I'm just going to do the opposite. The opposite of a positive 5 is a negative 5. But that gives me my center. Now I'm going to do the radius. And here's where I said be very, very careful. Because this 9 is r squared. It's not r squared. So the square root of 9 is going to be a 3. And that's my radius. Now recall when I told you, let me draw this picture of this circle, I said, watch. I don't do the loop around and put the center in afterwards. I put the center in first and then loop around from there, that fixed distance. So that means when I go to graph this circle, what I'm going to do is I'm going to say, okay, let's find 3, negative 5. 1, 2, 3, 1, 2, 3, 4, 5. That's going to sit right here. And now I'm going to go that radius of 3. So what that means is from here I'm going to come up 3, land me here. I'm going to go back 3, land me here. I'm going to go down 3 and land me way down here. And then I'm going to go to the right 3 and land me right there. And then I'm going to loop my circle around. Now technically it would be much better if I would go on a diagonal 3 and a diagonal 3, but oftentimes that's a little difficult to do. So just go up the radius, left the radius, down the radius, right the radius, and that will be plenty to get your circle. And you know that I like to have that smiley face in there, just because it makes me happy. But you don't have to do that. What you definitely need is that center. You definitely need these points out here based on the radius going out 3, up 3, down 3. Now let's take a look at this concept of the domain and the range. We've done domain and range before. That's nothing new. Domain, remember, is all of your x values. So what domain does is it says, let's take a look at our graph here. And let's say, what are all the x values that are covered by all these points? And remember, I like to do what I call that squishy game, which means if I'm talking about the x values, the x-axis, I'm going to take this graph and I'm going to squish it up here on that x-axis. When I do, all of these points will come up, 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 up like this. And these points will continue to come up, 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 like that. So everything from a 0 to a 6 got covered by that graph. So that means that my domain is going to go from a 0 to a 6. And remember, the 0 is a part of it. The 6 is a part of it. They are included in that. So they get a bracket because they are included. That's old information coming back to haunt you. So now the range, let's look at this concept of range. Remember, if domain is x, that means range is y. So what's going to happen now is I'm going to take my circle and I'm going to say, well, what y values are getting covered here? And so what I could do is I could say, well, let's do that squish thing again. So let's squish it over on that y-axis, and when I do, this point's coming over here. All of these are coming like this. These are all going to come over like this. So basically everything from a -8 up to a -2 got covered. So, and we always start with the smallest. -8 to a -2 got covered for my range. And remember that -8 is a part of it, so it gets a bracket. The -2 is a part of it, so it gets a bracket as well. So this is how you graph it. If you've got the equation, you can pull out the center, and you can pull out that radius. You can put the center on there, count the radius out, and then domain and range, again, is old school stuff that we talked about before. Domain is all your x values. Squish it on the x-axis. Range is y values. Squish it on the y-axis, and that will give you your domain and range. So hopefully this helps you with identifying parts of a circle, being able to take information and write the equation of a circle, being able to take the equation and pull information out, and then if you've got a center at 0, 0. And again, it is all based on this equation that you see right here. That is the equation of a circle in standard form. And hopefully it helps to know that it's very similar to the equation for a parabola, and that ought to make the memorization a whole lot easier to do. Have a great day.